Okay, guys, we're in Math 3 notes. Go to your table of contents. You guys at some point should have added in solving radicals. That was one of the ones we glued in. But you also should have taken notes on simplify rationals and add subtract rationals. Today we're going to do simplifying radicals. You already pretty much know it, but here we go. Okay, so turn to whatever page that's on, add that number to your table of contents. And here, simplify radicals. So our rules, there's two rules basically. If you are multiplying two numbers under a square root or radical, you can actually separate those two numbers out. And then also, if you are dividing them, you can also separate them. So an example of that, to simplify them, I'm going to use prime factorization. So our first problem we're going to do is square root 28. So with square root 28, I break that down into 2 times 2 times 7. That's its prime factors. So I can actually rewrite that, since I have two 2's, as 2 squared. And then I can separate that out. I can make that square root 2 squared and square root 7. Well, squares and square roots cancel each other out. So that actually just becomes 2 square root 7. Okay. The other way you could look at it is, and if you want to add this in, you can. I could actually do 28 square root 28 as square root 4 times 7. And then we can separate that square root of 4 times the square root of 7. And that would give me square root of 4 is 2 square root 7. This sometimes is a lot easier when the numbers are smaller. Prime factorization is better when the numbers are bigger, like square root of 192. Square root of 192, I would want to look for its prime factors. But if they're small numbers, like square root of, 20, I can break that down into 4 times 5. I know the square root of 4. Or 40. So, yeah. Okay, so the next one I've got here is the square root of 11 over the square root of 25. Square root of 11, you can separate it. Square root of 11 we don't know, so we keep it the same. Square root of 25 is 5. And the last one in this section is, and this one gets a little messy, sorry, square root of 50 over 81. So since it is division, we can separate those out. So that becomes square root 50 over square root 81. We know the square root of 81. It is 9. 50 we don't know, so we would break it down. 50 is 5 times 5 times 2. So 5 times 5 times 2. That's a 9 right there, sorry. So the square, 5 times 5 is 25 times 2. You could have also thought of 50 as square root of 25 times 2, which is square root of 25 times the square root of 2, since you can separate them out, is 5 square root 2. Or you can write it like that. 5 squared cancels out. Okay. So there are operations on I just realized I've got to add something in there. Operations on radicals. So the first one we have is 5 square root 7 minus 2 square root 7. As long as they have the same radical, you can actually just, it's like combining like terms. I've got 5 of them here. I'm taking away 2 of them here. I'm left with 5 minus 2, 3 square root 7. Now, if you are going to add them, though, they have to have the same radical. So for this one, we would have to simplify both of them. So square root 27, you can use the prime factors, or you can find your biggest perfect square. So I'm going to use the biggest perfect square for space reasons, but you can always use prime factor just like I did here. So 27 is 9 times 3. So that would be square root 9 times the square root of 3. I know what the square root of 9 is. It's 3, and that's square root 3, because we don't know it. Plus 75 is 25 times 3. 25 times 3. Square root of 25 is, now we can separate it. Sorry, square root of 3. Square root of 25 is 5. We don't know the square root of 3. Now, since they have the same root, we can actually add them. So now it's just like this problem, we can add them. So 3 plus 5 is 8 root 3. Now with multiplication, I forgot to add that in here. With multiplication, you can just multiply anything under a radical. So let's do 2 square root 3 times 4 square root 5. So if you were to multiply these, you can multiply the 2 and the 4 because they're not under the radical. Okay, so 2 times 4. And then you can also multiply the numbers under the radical. Square root 3 times square root 5, so 3 times 5. So that would be 8 square root 15. Okay, so with division, which is what this one is, I already have some steps here. I'm going to cover them up so you guys can kind of pay attention. Math does not allow radicals in the denominator. So we've got square root 4 over 10. We can separate those out. Square root 4 over square root 10. We can actually, we know the square root of 4, it is 2. We don't know the square root of 10. But unfortunately, we don't know, or we're not allowed to have a radical in the denominator. So we have to get rid of it. How do we do that? Well, this is a radical, it's a square root. So what undoes that? A square. A square undoes a square root. So if I square this, then I can get rid of it. So to square it, I would multiply it times itself. That's what squaring is, right? That's a 1 right there. So times square root of 10. But because it's a fraction, we have to keep it equivalent, which means we have to multiply the top and the bottom. So here we then have 2 times square root 10. And on the bottom we have square root 10 times itself. So we have square root 10 squared. These two can cancel. So we're left with 2 square root 10. You are allowed to have square roots in the numerator, just not the denominator. So we're fine here. Now we would see, does it reduce? If you reduce it, you can only reduce the numbers outside here, the radical. You cannot reduce the ones inside. Inside with inside you can, but out without you cannot. So you could not cross off these 10s. Because this really isn't 10, it's a square root of 10, which is 3 point something. This is the number 2 times 3.1-ish. So it's not 10, so you can't cross it off with a 10. However, we can reduce 2 over 10 to 1 over 5. Do I need to write the 1? No. If you have a little 1 written right there, that's fine. But 2 over 10 reduces. 2 over 10 reduces to 1 over 5, if you want to add that in. Okay, so that's how you would simplify radicals. You guys will need this for the quadratic formula. And when we get into higher degree polynomials. So make sure you have it.